Okay, so matter. What is matter? We'll simply define it as anything that has mass and occupies space. So some examples we can talk about are, water, a desk, people. Um, but anything that has mass and occupies space is going to be considered matter. Some things that are not matter, well, really the only one we really talk about is light. It can be different wavelengths of light, but light does not have mass. If you shine a flashlight on your hand, it doesn't push your hand down. So when looking at matter, we're going to talk about three different phases or states of matter. There actually is a fourth we'll talk about in chemistry called plasma, but we're going to, in this class, keep it to solids, liquids, and gases. You know, how do they differ, different transitions they can take, and things like that. So solids, when we look at them, they're tightly packed, atoms or molecules. And if you look at it, they're very structured and organized. They have a definite volume. So if you take a rock and you put it in a cup, it doesn't change its volume to fill up the cup. Same thing with its shape. It's not going to conform its shape to fill that cup. Some people might say, well, if I pour sugar, it takes the shape of the cup. Well, the individual pieces of the solid do not actually change their shape. Liquids are similar to solids in that they are fairly close. The molecules, think of a bag full of marbles. They're all in there. They're able to slide past each other, but they are fairly close. They have definite volume. So again, if I poured 1 cup of water into a gallon jug, it doesn't fill the gallon up. But it does take the shape of the container. So that cup of water would look different in a graduated cylinder versus a bowl versus a cup. Gases are different from both solids and liquids, that the molecules are very far apart. The atoms or molecules are widely spaced out, and they move around very quickly. And they bounce off each other. So think of a bunch of pool balls on a pool table just bouncing off each other repeatedly. They fit the volume of their vessel. So again, if I took a cup of gas and I put it into a quart, it would actually expand. The space between the molecules would increase and would fill that entire volume. And it will also take the shape of any vessel it's in. So if I had a container, a cylinder of gas, and I released it into this room, it would actually fill up the entire room. So we have the basics of matter being solids, liquids, and gases. Now we can actually look at another way that this is a flow chart, how we can describe matter. So matter is either going to be pure or it's going to be a mixture. So it can be something pure, have a definite composition, be homogeneous, or it can be a mixture that's actually made up of varying things. So let's go to pure substances first, even though it's on the right. So we can either have an element, so that's something from the periodic table. It's basically made up of individual atoms of, let's say, sodium or oxygen or copper. And those things are elements right off the periodic table. If you combine 2 or more of those elements or atoms of those elements, we get compounds. So if we look at salt, sodium chloride, that's a compound. If we look at water, H2O, 2 hydrogens and 1 oxygen make a compound water. Those in themselves are pure substances. When we look at mixtures, we can have heterogeneous or homogeneous mixtures. So we're mixing these elements and compounds. Homogeneous means that they look the same. They're uniform when we look at it. So if I took a little bit of sugar and put it in water, the sugar disappears. We don't see it anymore, and it looks like that could just be a cup of water. It has one uniform appearance. Let's say I took some rocks and put it in that water. Well, the rocks don't dissolve readily in the water, we'll assume, and that would be a heterogeneous mixture, not uniform. So you can see there's different things. If I mixed oil and water, we would have 2 phases. That would also be a heterogeneous mixture. 2 things that do not have a uniform appearance. You'd get a nice separation layer of the oil and the water. Those can be broken down further, but for this course, we're not going to really get into suspensions and colloids and solutions and things like that.